In this video, we are trying to solve a problem. See this. O is the center of the circle of radius OR is equal to 13 centimeters, 13 units. Another circle with center P is inscribed in the circle of radius 13 units and touching the circumference of the outer circle at point C. A chord AB is drawn to the outer circle passing through the center P. Find the length of the chord AB. So read the question once more. Once you read it, you'll see how the figure will be. Now let us see the figure. This is how the figure will look. Okay. Now, let us take it. So this is the question which I've already read. Now the figure is this. So if you see here, O is the center of this outer circle. And OR is the radius of this outer circle. And the radius is 13 units. Inside this circle, you have a circle, another circle, smaller circle inscribed in it and touching the outer circle at point C. P is the center of this inner circle. Okay. Now we are drawing a chord AB. This is a chord is drawn through the center P. We have to find the length of this chord. I hope you understood the figure. Okay, you have to find the length of the chord AB. Let's start. Solution. We will solve this in two methods. Let me first explain the first method. This is the first method which we are doing it. Here, OR, which is this OR? OR is the radius of the outer circle, which is 13 units. This is given. Therefore, OC and OD is also the radius of the outer circle. OC, OD is the radius of this outer circle because O is the center of the circle. The first sentence tells. So O is the center of the circle. So OC and OD both are 13 units. CD is the diameter of the outer circle. CD, this full length, is the diameter. From here to here, OC is 13 and OD is also 13. That means the diameter is 13 into 2, 26 units. But CD is equal to CS plus SD. To see this figure, CS plus SD. And SD is given 10. So let's substitute that. And CD, which is CD, is 26 units. So we have written CD is equal to 26. CS we do not know. And SD is 10. It is given here. SD is 10. Let us calculate this. CS is equal to 26 minus 10, that is 16 units. CS is 16 units. But what is the CS? You see the figure, CS is nothing but the diameter of the inner circle. So, CS is the diameter of the inner circle, which is 16 units. So, what you can say, the radius of the inner circle, that is CP, this much, or is also equal to CF, is also equal to PE, is equal to 8 units because radius is half of the diameter. So it is 8 units. So P is the midpoint of EF. So P is the midpoint of EF because this is the center of the circle and this is the diameter of the circle. Therefore, P is the midpoint of EF. So the line joining, now this we are using a rule here. the line joining the center O of the circle to the midpoint P of the chord EF is perpendicular to the chord. It's a rule, okay? If from the center, if you join the midpoint to a chord, any chord, it will be the center of the chord. So in this case, I have specifically, actually it's a theorem, that is line joining the center of a circle to the center of a circle to the midpoint of a chord bisects the chord. This is the thing. Now, write the theorem. Instead of writing the theorem, I just wrote in terms of the in relation with the figure. So, center of the circle, a line from the center of the circle perpendicular to joining the midpoint of the chord. So center of the circle means O, midpoint of the chord is P, so therefore this OP must be perpendicular to the chord. Okay, that means OP is perpendicular to EF. Okay, we get this first condition. OP is perpendicular to EF. Now, this is a figure. Perpendicular from the center of the circle to the chord bisects the chord. Perpendicular from the center of the circle to the chord bisects the chord. Therefore, AP is equal to PB. AP is equal to PB. Hope I am clear. But AP, what is AP? AE plus EP. And what is PB? PB is equal to PF plus FB. From the figure it is. It's clear from the figure. This plus this is equal to this plus this. Because AP is equal to PB. Now, PE and PF are the radius of the inner circle, and which we know it is 8 centimeter, 8 units. So, AE plus 8 is equal to 8 plus FB. 8 cancels. So, you will get AE is equal to FB. Okay, this is one of the conditions. So, let's keep this. This is one condition. Next. OC is the radius of the outer circle. OC. OC is the radius of the outer circle, isn't it? And which is equal to 13 units. If OC is the radius of the outer circle and it is 13 units, now you know OC is equal to, if you see this OC, it is CP plus OP. This plus this is equal to OC. And what is CP? CP is the radius of the inner circle, and which we know it is as 8. So let us put the values. And what is OC? OC is the radius of the outer circle, which is equal to 13. So let's put the two values here. 13 is equal to 8 plus OP. So what you get? OP is equal to 13 minus 8 is 5 units. That means this length from here to here, it is 5 units. Okay. Now, this is 90 degrees and this length is known, and we know this has a radius of the outer circle. So you can try to calculate this. How do you calculate? So OPB is a right triangle because this is 90. Okay. This is a 90 degrees. Therefore, this becomes a right angle triangle. When you say right angle triangle, the first thing that occurs to you is that Pythagoras theorem can be applied. So let's apply the Pythagoras theorem. Therefore, by Pythagoras theorem, we have, if this is 90 degrees here, what will be the condition? OB square, that is hypotenuse square, is equal to sum of the other two squares. So that is PB square plus OP square. This square plus this square is this. But OB is known as 13. OP, you know it as 5, which you have just calculated. Let's put the two values. 13 square is equal to PB. PB is PF plus FB. So let us PF plus FB. So 13 square is equal to PF is 8. Radius of the inner circle plus FB square is equal to 5 square. 13 square is 169. 8 plus FB square is equal to 25. 5 square is 25. Let's take 25 this side and subtract. 169 minus 25 is equal to 8 plus FB square. 169 minus 24 is 144. 8 plus FB square. Let's take the square root of both sides. Taking square root of both sides. Square root of 144 is equal to square root of 8 plus FB. The square and root cancels, and square root of 144 is plus minus 12. So it is plus minus 12 is equal to 8 plus FB. So that means two possible values are there. It is plus 12 minus 12. So let us take FB is equal to, first let us take positive value. So it is FB is equal to 12 positive value minus 8, that is 4 units. That means AE is 4 units. Why? Because FB, see this condition, FB is equal to AE. FB is equal to AE. That's why FA is equal to 4 units again. That is also equal to AE. Now let us take minus 12. Then what will happen? FB is equal to minus 12 minus 8 is equal to minus 20 units. But what is FB? FB is a length, and length cannot be negative. So we reject the value minus 20. So if this is rejected, so what happens? AB is equal to AE plus EF plus FB. Okay. AE is how much? We have just calculated as 4. EF is the diameter of the inner circle, which is 16. And again FB is 4. So 4 plus 16 plus 4 is 24 units. So this is your answer. Got it? So AB is 24 units. So this is the first method of calculating the length of the chord AB under such conditions. Now let's go for the second method. Now the second method is method 2. The figure is same. Okay. Now, what does this method says? For this method, we are again using a different theorem. Intersecting chord theorem it is called. Intersecting chord theorem. If two chords of a circle intersect within the circle or inside the circle, then the product of the segment of one chord is equal to the product of the corresponding segment of the other chord. If two chords of a circle intersect within the circle, that means they are intersecting inside the circle, and the two circles, when they intersect, they form two parts. So the figure will be like this. This is how the figure looks. Clear? Just see the figure. So two chords intersecting inside the chord. The segments of this, that means this is one segment of this chord, which is named at A. The other segment of this chord is B. The second chord, this segment we take it as C, and this segment is as D. So the product of the segments, that means A into B is equal to C into D. A into B is equal to C into D. We are using this concept here. Now, if you see our figure, in the figure, the two chords are AB and CD intersecting at P. Now you see, AB is a chord, CD is another chord, both are intersecting at P. Clear? So it is, that means how it will be as per this theorem, what should be? Therefore, by intersecting chord theorem, it should be AP into PB is equal to CP into PD. CP into PD. Clear? Next, AP. What is AP? AP is AE plus EP. And what is PB? PB is equal to PF plus FB is equal to CP and PD. What is PD? PD is PS plus SD. PS plus SD. Now let's put the values. Now you know EP. EP is the radius of this. EP is radius 8. PF is also radius 8. And FB is equal to AE. We have just proved previously. So CP into 8 plus 10. Okay. So 8 plus AE plus 8, AE plus 8. That means AE plus 8 whole square is equal to 8 into 18. Multiply this. AE plus 8 whole square is equal to 144. Square root of both sides. Root AE plus 8 whole square is equal to root of 144. Square and root cancels. So you will be left with AE is equal to 8 plus minus root 12. Again, AE is equal to 12 minus 8, 4 units. AE is also minus 12 minus 8, that is minus 20, which gets rejected. Therefore, AE is equal to FB is equal to 4 units. In that case, our AE is equal to AE plus EF plus FB, that is equal to 4 plus 16 plus 4, that is 24 units. This is your answer. So in either of the two methods, we get the same answer. Hope you have understood it. I think I have explained it quite simply. Thank you for watching it. Did you like it? If you have liked it, then subscribe. Click the bell icon and share it with your friends so that even they can benefit from all your things.